Hey, this is Lab Report 1, analyzing constant speed in the same direction. So the purpose of this lab is to analyze the motion of an object moving at constant velocity using principles of Newton's second law and or momentum principle. The focus of this lab will be delta P equals m delta V. So the synopsis of the lab, so an orange was rolled over the desk over a short time interval. It was analyzed over 33 frames, which is about a half-second time interval. Data points later on revealed that the motion was actually non-uniform. Total distance traveled was roughly 0.2 meters, and the system was just the desk in the orange. The items on the desk were out of the way. So initial conditions and assumptions. So the initial position of the orange is 0, and there's no velocity in the y direction. Net force is assumed to be 0 after initial contact from my hand. Friction is negligent or 0 because of that. And then the orange is assumed to be a smooth, perfect sphere. So this is the video of the orange moving across the desk. That was in real time, and then in 0.25 times speed. By the naked eye, it still looks like it's moving constant. These are the data points. And as you can see, for some of the displacement throughout the time interval is that the orange actually moves slightly backwards, which will be talked about more later. This is the model of the observed data, and once again, you can see how the motion almost oscillates up until it reaches 0.2 meters. And this is the code for the other aspect of the experiment. So the only changes that were made were the velocity and the initial position, and also the sphere radius, and also later on the time interval. So assumptions for the code were the initial velocity is the same as the final, and it was also assumed that the initial velocity was just the same as the average velocity of the motion. The position is 0, 0, and the net force is assumed to be 0, which also would indicate no change in momentum. This is the simulation model. The yellow sphere is the origin, and then the blue sphere is the end position of the motion. The green line represents the displacement. Based upon the code, this is the predicted model, and the position versus time graph is just a straight line starting at 0 and ending at 0.2 meters at time equals 0.5, and then the velocity is just a constant straight line at 0.4 of y equals 0.4. So sources of error throughout the project, throughout the lab, the biggest error was that the data indicated there was non-uniform motion, and there was a couple of causes. Possible causes. The main cause likely was that friction was not negligent. The desk likely created some friction, and also coupled with the fact that the orange is not a perfect sphere, as you could tell throughout the video. So after basically flipping the direction of negative x and positive x would lead to an equal magnitude, but opposite velocity and displacement throughout the motion. And then flipping the negative y and positive y axis would not have any effect on the results since there was no motion in that axis. So it's possible to observe the push and pulls. Net force was 0. There would be no friction, so there would be no push-pull motion happening. If the net force was non-zero, there'd be kinetic friction against the orange, which would show the push and pulls, which happened throughout the video. When observing moving objects, seemingly constant motion is affected by friction. So momentum is changing throughout the video, and the net force is non-zero, which is usually how it works in real life situations. And the shape of the object is also a factor in the motion.